professor in the Department of Computer Science and Engineering in the College of Rohini College of Engineering and Technology. The code is 8088 wireless ad hoc and sensor network. It is key distribution and management techniques in MANET and wireless ad hoc networks with limited computational ability. They allow dynamic addition and removal of nodes from the network. They may be subjected to surreptitious use surreptitious use by the enemy. So DNS requires cryptographic protection of communication, sensor capture, detection, keys, revocation. The best ways are symmetric key ciphers, low energy authenticated energy modes, and hash functions are the tools of choice for protecting the communication. So traditional approaches to the problem are impractical for sensor networks as their network topology is unknown, range limitations. Key pre-distribution is a distribution, a single machine key. It compresses the whole system. Say set up separate n-1 keys, each being pairwise privately shared with another node. So must be installed in every sensor, which renders it impractical for sensor node. Pairwise private key sharing between any two sensor node is unusable. Incremental addition and deletion as well as rekeying of sensor nodes could become both expensive and complex. A dedicated RAM memory for storage distribution, the basic concepts, generation of keys and key identifiers, random drawing of keys to establish key ring of a sensor, loading the key ring in memory of each sensor, saving of the key identifier and associated sensor identifier on a trusted controller mode, so loading the controller mode with key shared with that node. Revocation, you have to, whenever the communication is over, you have to revocate the keys. Rekeying, resilience to sensor distribution discovery phase. It takes during initialization. Each node discovers its neighbor and who its key is shared with. This can be done by broadcasting. So to avoid broadcasting, you have to have the private shared key discovery. For example, every key on the key ring, each node should broadcast list EK of alpha. Alpha I values ranges from 1 to k, where alpha is a challenge. So the description of EKF alpha is a property by a discipline would reveal the challenge alpha and establish a shared key with the broadcasting node. This would force attackers to perform traffic analysis to discover the pattern of pairwise key sharing is shown in the diagram. Establishes a topology of the sensor array as seen by the routing layer of the sensor network. A link exists between the two sensor nodes only if they share a key. If the link between two nodes exists, the communication will be secured by the link encryption. It may be possible that a set of nodes shares the same key. It does not matter as its normal operation. The nodes trust each other during the revocation. Removal of keys for a node ensures that the keys are removed in the network. Key between the two sensor nodes don't have the direct path, but they have two or more links. The number of keys on the key rings are left unassigned to any link. Such provisioning of having some keys unassigned helps further during revocation or incremental addition of nodes as we shared key discovery phase of the path established. A sensor node is compromised. So to sign a list of key identifiers, the controller generates a signature key KE and unicasts it to each node by encrypting it with a key KCA. After obtaining the signature key, each node verifies the signature of the signed list of key identifiers, locates those identified in its key ring and removes the corresponding keys. So after this reconfiguration of nodes may be most sensor node, the lifetime of the key shared between nodes exceeds that of the two nodes. So it is possible that in some cases the lifetime of keys expires and rekeying must be done. Rekeying is equivalent with a self-revocation of a key by a node. After expired key removal, the affected nodes restart the shared key discovery. Possibly the path key is in two ways: active manipulation of sensor inputs complete physical control of the adversary. Key distribution much more robust. K less than n keys of single ring are obtained. Attacker has n by p chance. The probability that a shared key exists between two nodes. N is the number of network nodes. D is equal to p into multiplied by n minus 1 expected degree of the node. So the average number of edges connecting the nodes with its graphical design. To establish a shared set shared key connectivity, what value should D so that the sensor node of n nodes is connected? Given D and the number of nodes in n dash in a neighborhood, what value should the key ring size and the neighborhood connectivity is n dash of 40 nodes, and as C is equal to 11.5k, the value is given. The pool of 10 1 lakh keys, each node have to have k is equal to 250k, assuming that 128 bit keys plus 60 bit index. Upon the probabilistic key sharing, it's scalable. So accommodates 10 to 1 lakh nodes or more, permits incremental addition of sensor node. Flexibility, it saves sensor cost, and memory can be used in hostile and adaptive environments. Secure, comprise of key affects few links. Revocation and rekeying. Example, you have to explain in detail key distribution management technique in wireless sensor network.